Welcome to my YouTube channel. I am Acho Francis Devan. Today, we're going to be dealing with mathematics, indices to be precise. If you remember very well, when I was solving questions on general gas equations, I made mention of certain important mathematics topics which we ought to know, which will help us to be able to move around more swiftly in chemistry. Chemistry as a course cannot exist on its own without an efficient knowledge of mathematics. So topics like indices, change of subject of formula, sort, and so on and so fraction, all these things must come into play, number-based system and many more. So today we're going to go through indices to the best which we can to see how we can correlate these things in our chemistry as a whole. So indices or indicial equation is the method of shortening the product of numbers to a reasonable pattern or kind of. For example, if I'm having something like 8, this is 8, whoa. This is 8, and this 8 is the same thing as 2 times 2 times 2. So how then can I shorten this? I can easily say this is 3, there are 3 variables, so this is 2 raised to the power 3. It's a method of shortening what the product of numbers. This is a pattern in which we can shorten it, like I showed you earlier on 2 raised to the power 3. So this trend we can use to reduce any number we want to deal with. For example, if I have 16, which is the same thing as 2 times 2 times 2 times 2, 2 raised to the power 4, so this can just be taken to be 2 raised to the power 4, which is the 16. So, and this trend continues, so on and so forth. But then, most importantly, we have certain laws which we use to govern or to run through these indices. The first one is the multiplication law of indices. Let's take that. Multiplication law of indices states that when numbers with equal bases are multiplied, the powers are added. Their powers are added. Let's take, for example, 1. If I have, this is 1, 2 raised to the power 3 times 2 raised to the power 2 times 2 raised to the power 5. We say when numbers with equal bases are multiplied. Now, these are the bases of the numbers, and these are their index or the power. That's why we call it indices. We're concerned, or we focus more on the power, which is the index. So these are the index, and these are the bases. So when numbers with equal bases are multiplied, their powers are added. Then we will have something like 2 raised to the power 3 plus 2 plus 5, and this is 2 raised to the power 10 as our answer. So in multiplication law is direct. Whenever you multiply numbers with equal bases, we add them. Okay, let's take another example aside this. If I have 2 as a raised to the power 3 times a raised to the power 2, this will become a raised to the power 3 plus 2, which is a raised to the power 5. The trend continues. Now, another aspect of this multiplication law is when we multiply numbers that have different bases, we have to regroup the ones that are similar and evaluate them. Let's take that as 3. I have a raised to the power 2 times times b raised to the power 3 times a raised to the power 4 times b raised to the power 5. So if you check here, we have different bases. So I have to do collect the like term, those ones that are similar, bring them together. So I will have something like a raised to the power 2 times a raised to the power 4 times b raised to the power 3 times b raised to the power 5. So I have to regroup them. So in this manner, I cannot proceed. So these two, goes with the law that when number with equal basis are multiplied, we add their power. So here I will have my a raised to the power 2 plus 4 times b raised to the power 3 plus 5, and this is a raised to the power 6 times b raised to the power 8. So this is it. This thing goes in the what? Multiplication law. So if I want to take a real variable that have real numbers, let's see what that becomes. 2 raised to the power 3 times 3 raised to the power 4 times 2 raised to the power 2 times 2 raised to the power 1 times 2 raised to the power 3 raised to the power 1 times 3 raised to the power 4. I will bring them all together by regrouping them. So I have my 2 raised to the power 3 times 2 raised to the power 2 times 2 raised to the power 1 times 3 raised to the power 4 times 3 raised to the power 1 times 3 raised to the power 4. So with this, I have to regroup, proceed, evaluate. So here I have 2 raised to the power 3 plus 2 plus 1 times 3 raised to the power 4 plus 1 plus 4. Don't forget, multiplication law says when numbers with equal bases are multiplied, the powers are added. When also the numbers are mixed up, we have to regroup them and still proceed, which I am doing. So here becomes 2 raised to the power 6 times 3 raised to the power 9. Now, if I want to finalize and get to the answer, it's a whole lot of big numbers, so I have to use my calculator. 2 raised to the power 6 will give me 64 times 3 raised to the power 9 is 19683 times 64. The answer becomes 1259712. So if we're looking for the final answer, we can solve it down here if we want to. But for the purpose of mathematics or indices, we don't mind, we don't care even if you stop here. You're good, we are good. You get here, we understand how you get here. But if you are required to go beyond, you break it down to here. Okay. So let us take the division. The division law is when numbers with equal bases are divided, the power of the divisor is subtracted from that of the dividend. So let's take go the other way. So when numbers with equal bases are multiplied, the power of the divisor is subtracted from that of the dividend. So now, I have in the division law, so number 1, 2 raised to the power 3 divided by 2 raised to the power 2. This becomes 2 raised to the power 3 minus 2. We subtract their powers. The power of the divisor is subtracted from that of the dividend. This one is subtracted from that of the dividend. So this is 2 raised to the power 3 minus 2 is 1. 2 raised to the power 1 is 2. So this is our answer. Let's take another example. Let's call it example 2. A raised to the power 7 divided by a raised to the power 3. This is a raised to the power 7 minus 3. This is a raised to the power 4. This is your final answer. So that is it. In another way, if you want to break it down further, this a raised to the power 7 will become a times a times a times a, 1, 2, 3, 4, times a, 5, 6, 7, divided by a raised to the power 3, a times a times a. So if I cancel this divided by this, we'll go. I'm left with 1, 2, 3, 4. So this is a raised to the power 4. So this is another way to break it down. But we always appreciate this because if you're dealing with elaborate numbers like a raised to the power 25, you're not going to be writing this all through. So it's going to take all of our time. So we try to cut it down to use the simplified method of solving it. All right. So there will be cases where you will likely going to get a negative value in when you do this. Okay, let's take another example 3. If I have something like a raised to the power 2 divided by a raised to the power 5. This is a raised to the power 2 minus 5, and this is a raised to the power 2 minus 5 is minus 3. Now, this isn't all, but because we are still in division law, I cannot solve it further. Let's presume we do not know more than this, so we stop here. But this is found in the negative index law. When we get to negative index law, you understand that the answer doesn't end here. We're supposed to move further, a step further. But we're going to be patient till when we get there. We see how we're going to go through that. So this, for the time being, this is our answer, right? So this is the division law. We have another law called the Powers law of indices. Let's take that Powers law. Now, in the Powers law of indices states that when a number is raised to a certain power, which is again raised to another power, that number is said to be in powers. That the powers are multiplied together for final evaluation. Let's see what that implies. Example 1. When the number a is raised to a certain power b, which is again raised to another power c, this number a is said to be in powers, that the powers are multiplied together for final result. So this becomes a raised to the power b times c. This is a raised to the power bc. This is our first example. Let's see what we can do further. Let's take another example. Example 2 here. 3 raised to the power 2 raised to the power 3. This is the same thing as 3 raised to the power 2 times 3. This is 3 raised to the power 6. This is Powers law. When a number is raised to a certain power, which is again raised to another power, that number is said to be in powers. That the powers are multiplied together for final result. Okay, let's take another example here. 2 raised to the power 3 raised to the power b. This is 2 raised to the power 3 times b. This is 2 raised to the power 3b. So that is our answer. And so on and so forth. Even if we take this again, number 4, as 5 raised to the power 2 raised to the power 3. This is 5 raised to the power 2 times 3. This is 5 raised to the power 6. So we move on. So these are the basic examples. We can do this on and on and on and on. So I get a lot of examples. Let's look at another product power law. When the product of different factors are raised to a certain power, when the product of different factors are raised to what? A certain power, perhaps in the bracket, yes, the power is distributed over each other in the bracket. So when the product of different factors in the bracket are raised to a certain power, that power is distributed evenly to all the variables in the bracket. Let's take that. This is product power law. When the product of different factors, let's call it A, B, C. are raised to a certain power, that the power is distributed evenly into the various variables in the bracket. So this becomes a raised to the power 2 times b raised to the power 2 times c raised to the power 2. That's it. So we can equally say a squared, b squared, c squared is the same thing. These two are the same. So what if, let's take an example. This is 1, example 2. If we have something like 3b squared, that the power will be distributed evenly in it. So I'll have 3 squared times b squared. 3 squared is 9 times b squared, which is the same thing as 9b squared. Another example, 2 b raised to the power 3. This is 2 raised to the power 3 times b raised to the power 3. 2 raised to the power 3 is 8 times b raised to the power 3. This is 8b cubed. Now 2 raised to the power 3 is 8, being that 2 times 2 times 2, which is 2 raised to the power 3. 2 in 3 times. 2 times 2, 4. 4 times 2, 8. So 2 raised to the power 3 is 8 at all times. So this is the product power law. Let's look at the zero index law. The zero index law says that any number raised to the power 0 is 1. So I have a zero index law. Number 1. Any number raised to the power 0 is 1. Example, 3 raised to the power 0 is equals to 1. 2 raised to the power 0 is equals to 1. 9,100 or 1,000 raised to the power 0 is 1. 1 million raised to the power 0 is 1. A raised to the power 0 is 1. B raised to the power 0 is 1. Anything raised to the power 0 is 1. So we don't have to forget that. It is important because we're going to make use of it. We're going to apply it. There will be certain times where we're going to get across such things. If you don't remember the formulas or the laws, you find it difficult to break through that step. So it is important if you can apply all the laws at all times, you remember them, then you can get through without much trouble. Let's see, we're done with that. The root power. This power involves the method of showing the indices of different roots. So we show the indices of different roots. Let's take the first one, root power. This method involves showing the indices of different roots. 2 raised to the power 1 over 2 shows the square root of 2. 2 raised to the power 1 over 3 shows you the cube root of 2. 2 raised to the power 1 over 4 shows you the fourth root of 2. 2 raised to the power 1 over 7 shows you, gives you the seventh root of 2. On and on. So the root, this is what gives you the root. It shows you the indices of different roots, and that's all. So at all times, you should know that 1 over 2 is the same thing as square root. 1 over 3 is the cube root. 1 over 4 is the fourth root. 1 over 7 is the seventh root. 1 over 5 is the fifth root. And so on and so forth. We can do that. Let's check again if we have more. Okay, fraction index. In fraction index, say at times a number might be raised to the power which is fraction other than half. Remember, okay, the method of resolving this is by finding the value root, the end root of the denominator. All right. So in this case, it may not necessarily be 1 over 2. So what's the name again? Fraction index. Let's go there. It shows you the n root of numbers, which may not necessarily be what? 1 over 2. So let's take examples. 4 raised to the power 3 over 2. Number 1. 4 raised to the power 3 over 2. Now, what is down here forms the root. And here we have 2, so it's square root. So this becomes, since this is square root, this is my square root of 4 raised to the power of 3. What is up here give us the power, here down give us the root, and this is our 4. So, and that is, if I want to simplify this, the square root of 4 is 2 raised to the power 3, and this is 8. So this is first step. So let's look at the second question. 4 raised to the power 5 over 2. Remember, what is down here is our root. So the root is square root. So this is the square root of 4 raised to the power of 5. And this is the square root of 4 is 2 raised to the power of 5. 2 raised to the power of 5 is 32, if I'm not mistaken. How do we get that? 2 raised to the power of 5 is 32. Remember, I told us earlier on, this is 2 times 2, 3, 4, 5. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. That is how we got that. Okay, let's take another one. 8 raised to the power 4 over 3. 8 raised to the power 4 over 3. Now, this is the cube root of 8 raised to the power of 4. And this is, the cube root of 8 is 2. But how will I know that? There are many ways we can use our calculator to press that. You press, okay, the second function root 8, which will give you 2. But we can also use Powers law to break that down, okay? So now we know that the cube root is the same thing as 1 over 3. 1 over 3 means cube root. I have illustrated that earlier on. Then, let's see how can we do this without using our calculator, all right? To see how we turn the cube root of 8 to be what? 2. Now, this is it. So, the cube root of 8. So this is my 8 raised to the power 1 over 3. Remember, that is the same thing as the cube root of 8. This is the same thing as that, which is this. So I want to break this down before I bring the power. 8, according to Powers law, means we talked about the shortening of the product of variables, isn't it, as indices generally. So it means this 8 can be also written as 2 raised to the power 3 is 8. I can multiply 2 by itself 3 times, I get 8. So this is now raised to the power of 1 over 3. So I have transformed it into the Powers law of indices. And what does Powers law say is that when number with equal bases are multiplied, their powers are added. Sorry. Powers law says that when a number is raised to a certain power, which is again raised to another power, that the number 2 is said to be in powers, and the powers are multiplied together for final word result. So I will have 2 raised to the power 3, which is here, multiply their powers for final result times 1 over 3. So this is 2 raised to the power 3 times 1 is 3 over 3. 2 raised to the power 3 divided by 3 is 1. 2 raised to the power 1 is 2. So that is why the cube root of 8 is 2. I can use Powers law of indices to, I can apply any law to solve anything I want to solve based on what? Indices. So if that is true, my next step becomes 2 raised to the power 4. And this is 16. 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. That's how I got there. Okay, I think we are progressing. Let's take another one. Last one, negative index law. It said a number raised to a negative index equals the reciprocal of that number raised to the same positive index. Okay, let's take, where is it? Let's take some examples, all right? Okay. 3 raised to the power minus 2, negative index. 3 raised to the power minus 2. Negative index law states that a number raised to a negative index equals the reciprocal of this number raised to the same positive index. This minus 2 become positive. First, let's break it down. Now, this is equals to, I want to solve this, but let's, excuse me, let's take a unique approach to understand what we're saying. Now, they say a number raised to a negative index, okay, equals the reciprocal of that number. Now, this is 3. What is the reciprocal of 3? This is 3 over 1. Every 3 you see in the wall, every number you see in the wall is over 1 because it still gives you the same number. So, if I have 5, it's the same thing as 5 over 1 because 5 divided by 1 is 5. 3 divided by 1 is 3. So now, this is it. The number is this, but this is how it exists. We know it. Technically, we know that. So now, if this is the same thing as 3, now what is the reciprocal of this number? It's the same thing as 1. The reciprocal becomes 1 over 3. Okay? So this one now will be what the reciprocal is 1 over 5. Because I know that this number 10 is the same thing as 10 over 1. The reciprocal of 10 is 1 over 10. So you must begin to see these numbers in a different dimension to understand that there is a 1 down there. It's divided by 1 and give you the same thing. So if this is true, the law says that when a number is raised to a negative index, it is equal to the reciprocal of that number raised to the same positive index. Okay, now, this, I want to put it down. 3 is raised to a negative index. Now, what is it? It is equal to the reciprocal of 3, which is now 1 over 3, raised to the same positive index. What is the negative index before? It was minus 2. And I say raised to the same positive index, it becomes what? Plus 2. So I have the power to put 2 here, raised to the power 2. That 2 is positive. That is what the law says. When a number is raised to a negative index, it is equal to the reciprocal raised to the same positive index. The negative index becomes positive index. The number itself, you get a reciprocal of it, and we move on. Yes, it's clear. So this is the same thing as 1 over 9, because 3 squared is 9. And so on. Let's take another example, in case we don't get this well, we can understand it that way. Let's look at another one. 5 raised to the power minus 4. Example 2. 5 raised to the power minus 4. This is equal to, when a number is raised to a negative index, that number, it is equal to the reciprocal of that number raised to the same positive index. What is the reciprocal of 5? Is 1 over 5. Now, this 5 was raised to a negative index, which is minus 4. They said the reciprocal of 5 now is raised to the same positive index. The positive index of minus 4 becomes 4. So this is equal to 1 over 5 raised to the power 4. Should be 6 to 5 also. Okay. 5 raised to the power 4. 6 to 5. 6 to 5. These laws can be confusing if we do not follow the rudiment in studying it. It may looks difficult or confusing, but it is important that the laws are there. when we follow the laws the way they should be followed, this whole thing becomes simple. We enjoy it in a different way, okay? So I've been able to explain the basic laws which we need in indices. So we begin to take questions to see how to apply the law. One, all right? Okay, that's our first question. Now, we know that this is x divided by x. When number with equal bases are divided, the powers are subtracted. So, that one is correct. So, we also know that 81 divided by 9 is still 9. So, I may not want to trouble myself that much. It's just to apply the basic principles which I showed. Okay, first, 9 divided by itself one time, we go into 81 is 9 times. So I will have the next step here become x squared. This, I want to deal with this side, minus 5 over 9. Now, because this is 1 times this is this. Goes here is 9. So I'm still having my variable. I'm good. Alright? So now, if this is true, because this side of x is, when number with equal bases are divided, their powers are subtracted. Okay, the power of the divisor is subtracted from that of the dividend. So 2 will be minusing what? 5. So my next step becomes x raised to the power 2 minus 5 is minus 3 over 9. Now, is that all? No. From the negative index law, it says that when a number is raised to a negative index, it is equal to the reciprocal raised to the same positive index. So if I want to break this down, I will say this x now become 1 over x, the reciprocal raised to the positive index, which is 3. Okay? And here, down already, this one is what is up. There was a 9 down, so it will be times 9. So here I will have 1 over 9x raised to the power 3. Here the negative index law says when a number is raised to a negative index, it is equal to the reciprocal raised to the same positive index. And there was a 9 down, so times that 9 down. So it will become 1 over 9x raised to the power 3. So that is the application of the law. We'll continue to move. Let's take another question. Question 2 here. It says 16 raised to the power 3 over 4 times 4 raised to the power 1 over 2 over 8 raised to the power 5 over 3. Let's see what to do. Now, if you look at this question, there is something unique about 16, 4, and 8. Very, very unique. That thing is that these numbers can be reduced to have a common base. All of them can be reduced to have a common base. Now 16 is the same thing as 2 raised to the power 4. This is 2 raised to the power 3. This is 2 raised to the power 2. So I will have a common base which is 2. And if I have a common base which is 2, here is multiplication. What does the multiplication law say? Number with equal bases multiply, we add their powers. And when I am done adding the powers, now have the same common base here in division. Number with equal bases, the power of the divisor is subtracted from that of the dividend. So with that I can move on. So let's see how that can work. This is 2 raised to the power 4 is 16 now. Raised to the power of 3 over 4. Remember the powers law of indices. When a number is raised to a certain power, which is again raised to another power, this number 2 is said to be in powers. We multiply the powers by final result. So times 4, which is 2 raised to the power 2. Powers law counts again. Divide by 8. 2 raised to the power 3. Alright. 5 over 3. So if I move on to say I want to apply the powers law, so I will have 2 raised to the power 4 times 3 over 4 times 2 raised to the power 2 times 1 over 2 over 2 raised to the power 3 times 5 over 3. Now 4 times 3 is 12. 12 divided by 4 is 3. So I'll have 2 raised to the power 3 times 2 times 1 is 2 divided by 2. 2 divided by 2 is 1. So I'll have 2 raised to the power 1 over 3 times 5, 15. 15 divided by 3 is 5. So I'll have 2 raised to the power 5. Now, here, multiplication law says that number with equal bases multiply together, we add their power. So I will have 2 raised to the power 3 plus 1 over 2 raised to the power 5, which is 2 raised to the power 4 over 2 raised to the power 5. So from here, division law comes. Where number with equal bases are divided, the power of the divisor is subtracted from that of the divisor is subtracted from that of the dividend, and I will now have 2 raised to the power 4 minus 5. 4 minus 5, I will have 2 raised to the power minus 1. Now, another law comes, negative index. When the number is raised to a negative index, it is equal to the reciprocal of that number raised to the same positive index. So the reciprocal of this is 1 over 2 raised to the power, which is 1. So 2 raised to the power 1 is 2, so I have 1 over 2. So my answer is half. So if you look at it, it may look difficult from the beginning, but with the application of the laws which we have studied here together, you begin to see that in each step of the way, you'll be able to resolve it without any complexity. So that's what's happening now. Let's take more questions, please. Okay, let's go back to maybe simple questions before we go to the complex. Think so? Let's take this out. We should evaluate 8 raised to the power 1 over 3. Now, there are 2 ways we can solve this. We look for the cube root because it's over 3 in fractional index. It told us that. So we can look for the cube root of 8, which is 2. That is if you have your calculator to know that. But if you don't have your calculator, we can use the Powers law to resolve that. So first of all, this is the same thing as the cube root of 8 raised to the power of 1. This is the cube root of 8 is 2 raised to the power 1, and this is 2. But we can also use Powers law, that's fractional index. So we can use Powers law to break this down. So we have 8, which is 2 raised to the power 3 raised to the power 1 over 3. This is the Powers law. This is 2 raised to the power 3 times 1 over 3. We multiply 2 raised to the power 3 times 1 is 3 over 3. 2 raised to the power 3 divided by 3 is 1, and that is 2. 2 raised to the power 1 is 2. Any of this we can take. So let's leave it here. So this is it first. We multiply the powers for final results. So the powers have been multiplied 3 times 1 over 3. And this is 2 raised to the power 3 raised times 1 is 3 over 3. 3 divided by 3 is 1. 2 raised to the power 1 is 2. So that is simple, is shorter only if you are having your calculator. But what if you don't have this? You have to use this. It may seem longer, but it's easier. Let's take another question. 81 raised to the power 3 over 4. 81 raised to the power 3 over 4. So another thing is just to look for the fourth root of 81 raised to the power 3. You get your answer. But let's assume we do not have a scientific calculator, so we want to solve it using Powers law initiative. So 81 is the same thing as 3 raised to the power 3 raised to the power 4. 3 times 3, 9 times 3 to the 7 times 3, 81. 9 times 9 is 81. So it's 3 raised to the power 4. 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81. So if I raise this by 4, I get that. So here we are. And I have 3 raised to the power 4 raised to the power 3 over 4. 3 raised to the power, we multiply the powers for final evaluation. 4 times 3 over 4, this is 3 raised to the power 12 over 4. This is 3 raised to the power 12 over 4, 4, 3, 12. Now 3 raised to the power 3 is 27. That is our answer. Where is it? It says 27 raised to the power minus 2 over 3. See, 27 raised to the power minus 2 over 3. So first thing first, negative index law says that when a number is raised to a negative index, it is equal to the reciprocal raised to the same positive index. So the first thing to be done is, this is 1 over 27 raised to the power 2 over 3. That's the first thing to be done. Okay. I know, I can apply my powers law. 3 raised to the power 3 is 27. So I can now have 1 over 3 raised to the power 3, which is 27, all raised to the power 2 over 3. I now have 1 over 3 raised to the power 3 times 2 over 3. I come down this way. 1 over 3 raised to the power 3 times 2, 6. 6 divided by 3 is 2. So this becomes 1 over 9. Because 3 raised to the power 2 is 9. So we must always follow the laws diligently in order not to make mistakes. Let's take another one. The D says 64 raised to the power 5 over 6. D. 64 raised to the power 5 over 6. So 2 raised to the power 5 is 32. 2 raised to the power 6 should be 64. Let's see. 2 raised to the power 6 is 64. Okay, so this I know is 2 raised to the power 6 using what? Powers law. You see that? So Powers law seems to be very powerful now, you can see. So now let's go. I want to break this. This is 2 raised to the power 6. Open bracket, 5 over 6. 2 raised to the power 6 times 5 over 6. 2 raised to the power 6 times 5 is 30 over 6. This is 2 raised to the power 30 divided by 6 is 5. And this is 32. 6 times 5 is 30. So 30 divided by 6 is 5. 2 raised to the power 5 is 32. So that is our answer. Let's take another one. 16 over 81. Where is it? Okay. 16 over 81 raised to the power 3 over 4. E. 16 over 81 raised to the power 16 over 81, 3 over 4. So here, okay, we can put in product power law, where numbers in the bracket are raised to a certain power. That power is distributed evenly into the numbers in the bracket, okay? So here I can easily have, this is 16. First of all, before I start that, let me break them down. 16 is the same thing as 2 raised to the power 4, okay? Over 3 raised to the power 4. for this. All in bracket 3 over 4. Okay, that's correct. Now let's move on. Now I can distribute this into the various variables here. So here I will now have 2 raised to the power 4, which is this, open bracket 3 over 4, divided by 3 raised to the power 4, open bracket 3 over 4. Now here is 2 raised to the power 4 times 3 power slow, 4 times 3 over 4. 4 times 3 over 4 over 3 raised to the power 4 times 3 over 4. Okay, now here 4 times 3, 12. 12 divided by 4 is 3. So 2 raised to the power 3 over 3 raised to the power 3. 2 raised to the power 3 is 8. 3 raised to the power 3 is 27. So this is it. We move on. Let's take more questions. 16 over 81 raised to the power minus 3 over 4. So first thing is, this is a negative index law in as much as it has other laws to be applied. So it says that when a number is raised to a negative index, it is equal to the reciprocal of this number, okay, which is this over 1. It's now 1 over reciprocal raised to the same positive index, which is 16 over 81 raised to the same positive index. Okay, that's the first thing. We've done that. The next step is 1 over 16 is 2 raised to the power 4 over 3 raised to the power 4. All of these raised to the power 3 over 4. So if this is true, let's move on. This is 1 over 2 raised to the power 4 times 3 over 4 over 3 raised to the power, okay, 4 times 3 over 4, 3 over 4. I think I jumped a step here because I was supposed to first of all introduce them individually before I expatiate it. But let's still move on, it's okay. The next step is 1 over 2 raised to the power 12 over 4. 12 over 4 divided by 3 raised to the power 12 over 4. This is 1 over 12 over 4 is 3, so this is 2 raised to the power 3 divided by 3 raised to the power 3. Yes, we are not done. So this is 1 divided by this. So it's the same thing as saying 1 divided by 2 raised to the power 3 is 8 over 3 is 27. This is it. 1 divided by this. 1 divided by this. We are good. So this, according to fraction or Botman's, it says that this becomes 1 times 27 over 8. That when once this is changed to multiplication, the position of these variables will also change. So I have changed it to multiplication sign, so I have to change the positions of these variables. The 8, okay, 27 down goes up, and the other one comes down. So 1 times this is the same thing as 27 over 8, which is 8, 1, 8, 8, 2, 16, 8, 3, blah, blah. Okay, let's leave it. This is improper fraction, no problems. We can leave it at that, right? 16. 27 over 8 becomes our answer. So let's take another question. We are asked to simplify. This is G. Simplify 245 p raised to the power 3 q raised to the power minus 2 divided by 5 p raised to the power 5 q raised to the power minus 2. Oh, sorry, q raised to the power of minus 6. Okay, let me cross check. 245 p cubed q minus 2 over 5p raised to the power 5 q raised to the power minus 6. Okay, that's correct. Okay, from here we begin. This divided by this first. Let me see. 245 divided by 5 is 49. So now I have my roots here. This divided by this gives me 49. This is p. Let me use times p. There are two p here. You say when numbers with equal bases are divided, the powers are subtracted. So this becomes p raised to the power 3 minus 5 times, there are two q here. Q minus 2 minus 6. I guess we are good. This is q raised to the power minus 2. They say when numbers with equal bases are divided, their powers are subtracted. The power here is minus 6, so there will be minus before this minus 6. So since we should subtract, so this comes into play. So I go on. This is my 49 times p. 3 minus 5 is minus 2. So this is p raised to the power minus 2 times q raised to the power minus 2 plus 6. Minus times minus is plus. We move on. This is my 49 times this. Negative index law give us 1 over p squared times minus 2 plus 6 is plus 4 q raised to the power 4. So this is the same thing as the root of 9 over 49 times q raised to the power 4 over p squared. Now, what is the root? The root of 49 is 7 times the root of q4 is q2 over the root of p squared is p. How? Let me explain this and this. Let's start from here. The root of q raised to the power 4 is q squared. Yes. The root is the same thing as this is q raised to the power 4. It's the same thing as 1 over 2. So if I multiply this, so this is q raised to the power 4 times 1 is 4 over 2, which is q raised to the power 2. Then this is square. P raised to the power 2 times 1 over 2. 2 times 1 is 2. 2 divided by 2 is 1. So this is P. So in that sense, I now have 7q squared over P. So that's it. Let's take on something else. Decimal powers and bases. So decimal means we're having point values like 0.1, 0.2, all these are decimals. So decimal in powers, as in the index, the value up it could be decimal, and or the basis down could be decimal. So when we have this in indices, how do we resolve them? That's what they're trying to say. Sometimes the power or base of an expression may be in decimal form. The best approach is by converting such decimal to fractions before solving. The final answer may therefore be converted back to decimal if it is necessary, if it is required. So it's just almost the same thing. But the most important thing is how can we convert the decimal values into fractions, all right? So there we go. Decimal powers and bases. If we have a number like 0.1, this is a decimal value, we want to convert it into fraction. How do we do that? Now, you look here, the first variable here, you turn it into 1. And the next one become, okay, this is 1. And the next one become 0. So, in the real sense of it, 0.1 will become, if I want to change this, okay, I will take my main value here as 1, I take it out, then I put this down, so this become 1 over 10. And 1 over 10 is 0.1, if you check. So I have 1 divided by 10, which is 0.1. Let me break it down more. Yeah, the only real number here is 1. So I bring my 1 up over, I come down here, this become 1 and this become 0. So this is 10. So I bring it down here, this is 10. What if I have 0.01? This become, my real number here is 1 over, here is 100. This become 100. So this is out. Now, is it true that 1 over 100 is 0.01? 1 divided by 100 is true. It's 0.01. So if I have 0.532, the real number here is 532 over 1000. So this is 1000. So it becomes 532 over 1000. Will give me this 0.532. So I'm only showing us how can we, or how to convert from decimal to fractions, okay? So if we have known that, let us move on to solving real questions. So let me take this out. First question, 0.008. 0.008 raised to the power 1 over 3. Okay, 0.008 raised to the power 1 over 3. Okay, now, first I have to convert this into what? Fraction, before I can apply this. So this is my 8 over, this is 1, 0, 0, 0. So 1 over 1000, 1, 0, 0, 0, raised to the power 1 over 3. Now, 1000 is the same thing as 10 raised to the power of 3. 10 raised to the power 3 will give me 1000. So here, 8 is the same thing as 2 raised to the power 3. So I can easily have 2 raised to the power 3 over 10 raised to the power 3, open bracket, 1 over 3. So with this, I will use my Powers law, apply it. This is now 2 raised to the power 3 times 1 over 3 over 10 raised to the power 3 times 1 over 3. So here I will have 2 raised to the power 3 over 3, because 3 times 1 is 3, over 10 raised to the power 3 over 3. Now, 3 divided by 3 is 1. 3 divided by 3 is 1. So this is 2 raised to the power 1, which is 2, 10 raised to the power 1, which is 10. And this is, okay, let me come here. 1 over 5. 2 divided by itself is 1 time. 2 going to 10, 5 times, so 1 over 5. That's our answer. Let's take another example. Okay, B, if that is A, did I call that A? No, call it 1. Okay, let's call it 2. Under decimal, let's call it 2 now. Let's take this out. We can move on. 0.25 raised to the power minus, raised to the power of, minus 2. Okay. Yeah, again, we go. We'll convert this first to fraction. This is 25 over 100, 100, or raised to the power minus 2. Okay, we can divide this in the bracket. 25 going to itself is 1 time, going to 100 is 4 times, raised to the power of minus 2. Now, this minus means I can now take it to negative index. So this becomes 1 over 4, which is this, raised to the power of 2. So this is my 1 over, okay, yeah. 1 raised to the power 2 is 1. 4 raised to the power 2 is 16. So this becomes 1 divided by 1 over 16. This is 1 times 16 over 1. This is 16. So on and on. That's how we go. Let's take another question. 32 raised to the power 0.2. I guess it's clear. Here is the same, minus 2, the negative index is the reciprocal raised to the same positive index, and the product power law, when a number in the bracket is raised to a certain power, the power is distributed evenly into the variables in the bracket. So it means this 1 raised to the power 2, 4 raised to the power 2, and 1 raised to the power 2 is 1, 4 raised to the power 2 is 16, so 1 over that. Then I bring in fraction, but mass. When a number is divided by 16, I change it to multiplication sign by changing the positions. So this times this over this is this. Let's take another question. Example 3 is 32 raised to the power 0.2. 32 raised to the power 0.2. So 0.2 is the same thing as 2 over 10. 0.2. This is real number 2. Here is 1, 0. So this is 10. And 10 is the same thing as 1 over 5. So my power is 1 over 5. So this is 0.2 officially become 1 over 5. So let's see how we can use it to solve. So now, I now have 32 raised to the power 1 over 5. I look for the fifth root, or better still, Powers law of indices. Let me simplify. This is 2 raised to the power 5. Open bracket, 1 over 5. This is 2 raised to the power 5 times 1 over 5, which is 2 raised to the power 5 over 5, which is 2 raised to the power 1, which is 2. 16 raised to the power 5 over 4. 16 raised to the power, where is it? 5 over 4 times 2 raised to the power minus 3 times, where are you? 3 raised to the power 0. Okay. If you look very well, you see there is some uniqueness in what we're about to solve, which is the multiplication law. These two, I can bring this into having the same base with this. This is 16, which is the same thing as 2 raised to the power of 4. So I have 2 here, I have 2 here. But here is 3, they are not of the same base. How can I make them to have the same base? Zero index law says that any number raised to the power 0 is 1. I have 3 raised to the power 0 is 1. If 3 raised to the power 0 is 1, what about 2? 2 raised to the power 0 is also 1. Am I right? Which means I can use 2 raised to the power 0 here, provided the end product of this reaction is what? 1. 2 raised to the power 0 is equivalent to 1. If A is equals to 1, B is equals to 1, 1 is equals to 1. That is what it means. So if 3 raised to the power 0 is 1, 2 raised to the power 0 is 1, 1 is equals to 1, and 2 raised to the power 0 is equivalent to 3 raised to the power 0. So I can change this to 2 raised to the power 0 according to what the zero index law. Okay, now I will have, this is 2 raised to the power of 4 will give me 16. 5 over 4 times 2 raised to the power minus 3 times 3 raised to the power 0. Sorry. 2 raised to the power 0 because they are not the same thing. Now, this is 2 raised to the power 4 times 5, 20 over 4 times 2 raised to the power minus 3 times 2 raised to the power 0. Okay, without complications, let's see, I can add this, but because of the negative sign here, I don't want to bring in fraction, it may take my time. Let me apply the rules. The zero index, no, a negative index. So this becomes 2 raised to the power 20 divided by 4 is 5. 2 raised to the power 5 times 1 over 2 raised to the power 3 times 2 raised to the power 0. So this becomes 2 raised to the power 5 times 1 is the same thing, okay, times 2 raised to the power 0. So now I can say I have 2 raised to the power 5 times, here is 1, 1 is the same thing as 2 raised to the power 0 times this one, 2 raised to the power 0 over 2 raised to the power 3. 2 raised to the power 5 times 1 times, yes, this one is the same as 2 raised to the power 0, 3 raised to the power 0, anything raised to the power 0 is 1. So let me just use 2 because I have common base here is 2, common base here is 2, raised to the power 0. So the law says that when number with equal bases are multiplied, their powers are added. So I will be having 2 raised to the power 5 plus 0 over 2 raised to the power 3, and that is 2 raised to the power 5 over 2 raised to the power 3. This is equals to division law. When number with equal bases are divided, the power of the divisor is subtracted from that of the dividend. So this becomes 2 raised to the power 5 minus 3. This is 2 raised to the power of 2, and this is 2. 4. Alright. 5 minus 3 is 2. 2 raised to the power 2 is 4. That might mean. Okay. Let's solve more. I feel like solving more. Now where we have the decimal value being in the index. The one we dealt with the other time was in the index. So let's solve this one in the base. 0.25 raised to the power x is equals to 16. This is the same thing as 25 over 100. This is the real number is 25, 100. all raised to the power of x is equals to 16. This is the same thing as 1 over 4 raised to the power of x is equals to 16. Okay. Yeah, I can have a common base too. This is the same thing as 1. Okay, let's call it 4 raised to the power minus 1. This value. X is equals to 16. Negative index law says that when a number is raised to a negative index, it is equal to the reciprocal raised to the same positive index. So if I have 4 raised to the power minus 1, the reciprocal of this is 1 over 4 raised to the same positive index, which is 1. 4 raised to the power 1 is 4. So this is the same thing as this. So I just have to return it. But now the question is, why should I do that? Okay, you'll be asking. I'm trying to bring them into a common base. 4 can give me 2, 16 can give me 2. Because here I have the power of x. So I need to bring them into the same base and see if there's something I can cancel out. Okay? Now, let's move on. Now, okay, this is the same thing as 2 raised to the power of minus 2 raised to the power x. Okay? 2 raised to the power 2 times its power minus 2, so will give me that. So that is the same thing. All over 16. 16 now is 2 raised to the power 4. Two raised to the power 4 is 16. Power's law. 2 raised to the power minus 2 times this is minus 2x is equals to 2 raised to the power 4. So the bases are the same. Now I have the same base. Here I'm having x. Here there's no x. So there's obviously nothing I can do here. But here I have a common base which is 2. I can cancel that out and make use of their powers. So this will go. I have minus 2x is equals to 4. Divide both sides by minus 2. Minus 2. X is equals to 4 divided by 2 minus 2. 4 divided by 2 is 2, and the minus sign is there, so my answer is minus 2. So this is the principle which we can apply all the time. So this principle majorly, or this question will take us to what we call the exponential function, where we equate the variables, we cancel out, and we move on. So we'll see to that while we go into exponential functions. Let's take them now. Let's go there. In exponential function, we say when an unknown is the index or power, like the one we just solved, x was the unknown as the index. But this time they say either index or power of a function, that is a number, then it is an exponential function. Example, 3 raised to the power x is equals to 9. 3 raised to the power x is equals to 9. The x is unknown. That is an exponential function. So this can easily be saying 3 raised to the power x is equals to 3 raised to the power 2, because this will give us 9. This will cancel this because they are the same. X is equals to 2 in this case. So that is what we talk about exponential function. So the unknown can also be at the base. Such equation can only be solved if both sides can be expressed in the same base. So I have to express this, the both sides can be expressed in the same base. That is the only time I can solve it. If I can't express them to the same base, then I can't solve it. So in an exponential function, there will always be an unknown which you are looking for, x, y, z, whatever it is. But the the fact here is, if you can bring the both sides to have the same base or the same index, good. Then you can get to your answer. Let's take another question. 2 raised to the power x is equals to 16. 2 raised to the power x is equals to 16. 2 raised to the power x is there. This is equals to 16 is 2 raised to the power 4. So the 2 can cancel. X is equals to 4. So that is exponential function. We'll take more of this. Next question. Simplify x raised to the power 1 over 3. Simplify x raised to the power 1 over 3 is equals to x, what is it? Is equals to 3. Now, this change of subject or formula has taught us some basic principles which we use to solve things like this. This is indices, don't forget that. But there are other topics that can always come across it. So mathematics is a unified course or subject that its knowledge is vastly used almost in everything you do. So even in one topic or the other, you continue to see various other topics reflecting. So in change of subject, they've told us that when an unknown, let's say A, is raised to the power of 2, for you to make A to stand out alone as a subject, you root both sides. You multiply both sides, or you root it both sides by, that's in the square root, square root, both sides, and that take care of it. For example, if I have A raised to the power 2, I want to remove 2, I have to multiply it with 1 over 2, and 1 over 2 is square root. So that 2 times 1 is 2, divided by 2 is 1. A raised to the power 1, A is alone. The same thing applies when I have A raised to the power 1 over 2. For me to remove this, I will have to square it. The same law. So if this, I could root it to get rid of this, and in this other case, I can also square it to get rid of it. If you come here, this is 1 over 3, which is cube root, which means the only way to remove the cube root is to cube both sides, raise it to the power of 3. By so doing, you can take care of that. So let's see how that works. So for me to get rid of that, I have to raise it with the power of 3, multiply through. Yeah, not multiply through. Raise it to the power of 3. So this is x raised to the power 1 over 3 raised to the power 3 is equals to 3 raised to the power 3. So this is x raised to the power 1 times 3 is 3, divided by 3 is 1, or let's put it 3 over 3, is equals to 3 divided by raised to the power 3 is 27. This cancel this is 1, so x raised to the power 1 is x is equals to 27. So we go, let's see more. 27 raised to the power x plus 2. 27 raised to the power x plus 2 is equals to 9 raised to the power of 2x. 9 raised to the power 2x, okay? Now, what is common between these two is that I can reduce this to have a base of 3, and this I can also do the same. So here is 3 raised to the power of 3 will give me 27. All raised to the power of x plus 2 is equals to 3 raised to the power 2 here, all raised to the power 2x. Powers law of indices. When a number 3 is raised to a certain power 3, which is again raised to another power x plus 2, that this number 3 is said to be in powers, that the powers are multiplied together for final result. So I now have 3 raised to the power of 3 times x plus 2. That is what it means. It's equals to 3 raised to the power 2 times 2x. I will expand this fraction with talk about bracket. You resolve brackets for anything. So this is 3 raised to the power 3 times x is 3x plus 3 times 2 is 6. is equals to 3 raised to the power 2 times 2x is 4x. Now I have the same base. I cancel. I have 3x plus 6 is equals to 4x. Now, collection of like things. We are now in linear algebra, another topic in mathematics. So in linear algebra, we collect like things, right? So let's see, I now have 3x minus 4x is equals to minus 6. Collecting like term, this is my 3x, this is 4x, crosses over to this side. It was positive, becomes negative. I have minus 4x. And this is plus 6, cross over to the other side, becomes minus 6. So we'll collect like term, bring the variables that are like one side. Now 3x minus 4x is minus x. This is equal to minus 6. We divide both sides by minus sign to get rid of this, and I have x is equals to 6. Okay, let's take another question. 8 raised to the power x minus 3. 8 raised to the power x minus 3. Minus 3. Okay, x minus 3 is equals to 32 raised to the power x plus 2 over 4 raised to the power minus x. 4 raised to the power minus x. Let me certify. 8 raised to the power x minus 3 is equals to 32 raised to the power x plus 2 over 4 raised to the power minus x. Okay. Yeah. The good thing about them all is that they all have something in common. 2 is here, 2 is here, 2 is here. First thing to start with. So I want to start 2. I have here becomes 2 raised to the power 3, open bracket, x minus 3. Is equals to, here is 2 raised to the power 5, open bracket, x plus 2 over 2 raised to the power 2, open bracket, minus x. 2 raised to the power 3 times x is 3x minus 3 times 3 is 9. Is equals to 2 raised to the power 5 times x is 5x plus 5 times 2 is 10 over 2 raised to the power 2 times minus 2x is minus 2x. Okay. Let's cross multiply. Let me have them on the same platform. This is over 1. So by cross multiplication, this times this and this times this. So I have my 2 raised to the power 3x minus 9 times 2 raised to the power minus 2x is equals to 2 raised to the power 5x plus 10 times 1 is the same. Okay. With equal bases are multiplied, their powers are added. Let's add the powers. So this is 2 raised to the power 3x minus 9 plus minus 2x is equals to 2 raised to the power 5x plus 10. Okay, this is plus, so let me write it well. Plus. So this is 2 raised to the power 3x minus 9 plus times minus is minus 2x is equals to 2 raised to the power 5x plus 10. Now, the bases are the same. I cancel out. So this will cancel this. I have now 3x minus 9 minus 2x is equals to 5x plus 10. Collect like terms. Collect like terms. This is 3x minus 2x minus 5x is equals to 10 plus 9. Okay. 3x minus 2x minus 5x is minus 7x. So 3x minus 7x is equals to 19. Okay. 3x minus 7x is minus 4x. Minus 4x is equals to 19. Divide both sides by minus 4, minus 4. This will cancel this. X is equals to minus 4, 4, 4, 2, 8, 4, 3, 12, 4, 4, 16. 4, 4, 16, 17, 18, 19. Remember 3 over 4. Let's take another question. Solve for x in the equations. So let's take like 5, 6 more questions. We need to, this is the thing about mathematics. The more questions you solve, you begin to see the different angles in which one question can be resolved. Or probably maybe you've been taught of 1 or 2 questions, so you've seen those examples. But by the time you see like 5, 6, 7 examples related to that same thing, you have a broader understanding of what you're dealing with. Okay, your scope will be widened. So let's take another question. Okay, we'll call it number 4. Let's take 2x equals to 64. 2 raised to the power x is equals to 64. Okay, this seems more simplified compared to the last one we just saw. So I bring that to the same base. So this is 2 raised to the power x is equals to 2 raised to the power 6. 5 is 32 times 2, 64. So they are the same. I cancel my x is equals to 6. That's question 4. Question 5. 5 raised to the power x plus 1. X plus 1 is equals to 625. 625. So I have 5 raised to the power x plus 1 is equals to 5 raised to the power of 4. This will cancel this. I have x plus 1 is equals to 4. Collection of like terms. X is equals to 4 minus 1. X is equals to 3. That's my 5th question. Let's take some more. The 6th question. 4 raised to the power x plus 1. 4 raised to the power x plus 1 is equals to 8 raised to the power x plus 2. Bring them to the same base. This becomes 2 raised to the power 2 x plus 1 is equals to 2 raised to the power 3 x plus 2. Power's law, you multiply. This is 2 raised to the power 2 times x is 2x. 2 times 1 is 2. Is equals to 2 raised to the power 3 times x is 3x plus 3 times 2 is 6. I can cancel this. I have 2x plus 2 is equals to 3x plus 6. I collect like terms. 2x minus 3x is equals to 6 minus 2. This is minus x is equals to 4. Divide both sides by minus. X is equals to 4 minus. 2 minus 3 is minus x. 2x minus 3x minus x. So that's our 6th question. Let's go to the 7th. If 3 times 9, number 7. If 3 times 9 raised to the power 1 plus x is equals to 27 raised to the power minus x. 27 raised to the power minus x. So they say, if 3 times 9 raised to the power 1 plus x is equals to 27 raised to the power minus x, find x. Alright. If 3 times 9 raised to the power 1 plus x is equals to 27 raised to the power minus x, we should find x. Okay? Now all these numbers, I can have a common base, which is 3. So I have my 3 times 3 raised to the power 2, 1 plus x is equals to 3 raised to the power 3 minus x. Now this is raised to the power 1. So I have 3 raised to the power 1 times 3 raised to the power 2 times 1 is 2 plus 2 times x is 2x. This is equals to 3 raised to the power 3 times minus x is minus 3x. Now, multiplication law says that when numbers with equal bases are multiplied, their powers are added. So I now have 3 raised to the power 1 plus 2 plus 2x is equals to 3 raised to the power minus 3x. Now I take this out, they have the same base. 1 plus 2 is 3 plus 2x is equals to minus 3x. Collection of like terms. Okay, let's come this way. Collection of like terms. I have 2x, which is this. This is minus 3 crossover become plus 3x is equals to, this is my plus 3 crossover to this I become minus 3. Now this is 5x is equals to minus 3. Divide both sides by 5. Cancel. X is equals to minus 3 over 5. So that is our x. Now let us proceed. Let's take another question, the 8th question. The 8th question says 4 raised to the power x minus 16 is equals to 0. 8. 4 raised to the power x minus 16 is equals to 0. Okay, let me be sure. 4 raised to the power x minus 16 is equals to 0. Okay, from here, we take this guy out. It doesn't have x, so it's like collecting like terms. So we have 4 raised to the power x is equals to 16. And they have something in common, 4 exists here. So I have 4 raised to the power x is equals to 4 raised to the power 2, which will give me 16. So I have common base, cancel, my x is equals to 2. 9th question. Sixteen raised to the power 3 minus x. 16 raised to the power 3 minus x. 3 minus x is equals to 1. 16 raised to the power 3 minus x is equals to 1. Okay? If this is what it is. Now, this 1, there is no way we can equate it having the same base with this. But we know that any number raised to the power 0 is equals to 1 according to the 0 index law, which means I can turn this one into 16 and I'll have 16 raised to the power 0, which I know 16 raised to the power 0 is equivalent to 1, so that I'll have common basis. From there I can proceed further. Otherwise, there's nothing that can be done here. So, with that knowledge, I now have 16 raised to the power 3 minus x is equals to 16 raised to the power 0, because 16 raised to the power 0 is 1. Now, if this is true, I have the same base. I can now cancel this. 3 minus x is equals to 0. Collection of like terms minus x is equals to, this crossover become minus 3. The Bible says by minus, this cancel, my x is equals to 3. Because this will go. So that is it. Let us, now, how do you know you're correct? For example, let us just check. Okay, we say in every equation the left hand side must equal the right hand side. If x is 3, I put my 3 here. 3 minus 3 is 0. 16 raised to the power 0 is 1. So here is 1, here is 1. So by that you know you're correct.